Hi, welcome back. Now we're going to begin to talk about some concrete objects that we use, or class types, that we use over and over and over again in Objective-C development for iPhone apps. These are called plistable types, and their underlying XML representations are called pLists. So P in plist stands for property. So these types have properties, and there are three basic types with their mutable variations. So that's what we're going to discuss today. So we already said a plist is an XML representation of a list types. So what in the world is a list type? Well, list type in Objective-C is an NS array or an NS set or an NS dictionary or their mutable variations: NS mutable array, NS mutable set, and NS mutable dictionary. An array is a list of objects. A set is a set, an unordered set of objects. An NS set can only contain one unique object of any particular type. And a dictionary is like a Java hash, for lack of a better comparison. It has keys and values. The keys are strings, NS strings, and the values of an NS dictionary are objects. So these types, NS array, NS set, NS dictionary, together with their mutable variations, can only contain objects within them. They can't contain primitives. Now, there is a way to take things like integers and floats and doubles and so forth and wrap them in an object type called an NS number that will give us an object representation of, say, an integer type or a what have you. So back to pLists. pLists are used really to save the contents of a list type for some use later. So list types have methods to write their contents out to a plist file and to load their contents from the data in a plist file. Because pLists are XML, not only are they used within an application to load and save data, they're used between applications. They're a lightweight way to transfer data. They can be produced, for example, very easily from an online database using PHP or some other server-side language. And we can produce that plist representation and then present it within the application within an NS array or an NS dictionary or so forth. So pLists are extremely useful, and they're very easy to implement. We can also save data, as you might already know, into an SQLite 3 database, and we can also use something called core data, which we'll explore later in the course. But for now, a plist is our go-to way to save and load things that we want to maintain between runs of an application in case that application terminates. So let's talk a little bit about application termination. We used to trap the event, the lifecycle event in Objective-C. We used to trap that in the app delegate's application will terminate method to tell us when that application was going to terminate so that we could save our pLists. But in the modern way, my way, the way we're going to use in this course, is to save data to a plist every time the user makes a change, and to load any data that might have changed every time the application is run. Applications in iOS, in modern iOS 6 certainly, do not terminate by default. They are terminated under really two basic conditions. The first is that the system needs some memory, and so it will terminate an application that is in a suspended state to capture that memory back. When that happens, we don't really know when that happens, but application will terminate typically isn't called in response to the system recapturing memory from a suspended application. The other way that applications can be terminated is by the user going into the system itself and terminating the application on the device. In that case, and in that case only, application will terminate is called. But because we really don't know In most cases, in the case of system recapturing memory, we really don't know when that application is going to terminate. The best strategy, in my view, is to save state every time the user makes a change. If it's a plist object that's changing, and usually it is, if it's an NS array or NS set or NS dictionary or a mutable variation thereof, we'll save it out as a plist in the document folder on the device, and then load it back up the next time that application runs. So let's talk specifically about NS array. It's our first example of a class that is listable. So NS array is a plistable type. NS array is immutable, meaning it represents an array of objects, not primitive types, whose elements cannot be changed or added to or deleted from. So I hear you thinking probably, what good is that? If I have a C array, I can mutate that array all day long. Well, a C array is an array of primitive types. An NS array is an array of objects. So we have a pointer to an NS array type that is really just an array of pointers to other types. The two main methods of creating an NS array are an instance method called init with objects, that its parameter list is really just a list of objects that we're adding to the array, and then it's terminated, and it must be terminated, with a nil, which is no object. This gives us back, this is a nice method to have, it gives us back an actual array with a strong reference to it. In other words, this array that this method will give back, the instance method, it will give back an array, an NS array, with a reference count of 1. Now the other way is to use the class method that corresponds with this. This also returns an NS array, but we have a plus sign before it, meaning this is a class method. And this is array with objects. And then the list of objects, of course, it's terminated by a nil as well. This gives us back what we used to call an auto-released array. What it really means is it gives us back a weak reference array, an array that has a reference count of 0. We typically use the second form within a method to declare an array that we're going to play with for a little bit within this method, and then at the end of the method it goes away because it's got a reference count of 0. We use the strong reference, the instance method, init with objects, to create an array that we're going to keep, that we want to keep a reference to for a while. Then, when the view controller or the model object or whatever we have this array declared in is deallocated, is removed, then this array's reference goes away and it will be deleted from memory. Just like we talked about strong and weak properties, here we have strong and weak arrays created by init in the strong case or array with objects in the weak case. Objects within NS array are accessed using their indices. So we return an ID type because we don't know what that object type is. This is any object. And this method is called object at index. And then we give it an NS integer. And that pointer there, that asterisk, is a misprint. That shouldn't be there. NS integer is an alias for int. Pure and simple. It's a primitive type. So that pointer there before the parentheses, that's a mistake on my part. That should not be there. And then the index is, of course, the integer index of that object within the array. And that will return an object that corresponds to that indexed object in the array. The objects in an NS array can be of mixed type. They can be of any object type, any pointer type. NS mutable array is the mutable category, and there's a word that I haven't defined yet, but category. It's a mutable category on top of an NS array. It's also therefore listable. Anything you can do with an NS array, you can do with an NS mutable array. I'll talk about categories in Unit 4, but I'm going to kind of give you an idea of what that word means here in a moment. An NS mutable array represents an array of objects whose elements can be altered or added to or deleted from. When we create an NS mutable array, we use the same methods as NS array, init with objects or array with objects, depending on whether we want an auto-released version or an actual version that has a reference count of 1. Mutable array declares methods to add and delete objects or even delete all objects from the array. So a mutable array is kind of like a C array, array of primitives, except a mutable array is kind of like a C array with objects. And then, of course, we can get an object at a particular index, object at index, and so forth. We can get a mutable copy of an immutable array. In other words, we can call an instance method called mutable copy on an NS array, and what we get out of that is a mutable copy of that NS array. We get an NS mutable array that has the same contents as the NS array. Like I said, NS mutable array is a category on NS array. So categories in Objective-C are a way to add methods to an already existing class. So a mutable array is like a super NS array. It has methods to add and remove objects from that array, but those methods are part of the category that's declared on top of the NS array. The point is that a mutable array can be assigned directly to an immutable array. But in order to get an immutable array, in order to get an immutable array from a, let's do that again. In order to get a mutable array from an immutable array, we have to use this mutable copy method. So the assignment is one way. It's almost like a NS array being a superclass of NS mutable array. We can get a mutable array by calling the mutable copy method of the immutable array, but we can get a immutable array just by declaring a mutable array to be of type immutable array. I hope that makes sense. The demo with an array makes a little bit more sense, and as we use mutable arrays and immutable arrays, this will become second nature. It really is much more difficult to describe than to do in code. So you have some assignments, and I'm going to give you these assignments for this unit. The first assignment, of course, is to view all the demos, but don't just look at the demos. Actually play with that demo code to get some more understanding of what's going on. The demos here in Unit 2 are very, very simple. But I want you to play with the code and add to it and delete from it and make sure that you fully understand what's going on in these demos. Next thing I want you to do is to look at the Xcode organizer documentation on NS array and NS mutable array, and also look at the documentation on pLIsts. The third thing is, in Xcode, declare a property that is an NS array, and declare that property to be non-atomic and strong, and call it myArray. And then investigate the header for the NS array class by command clicking on NS array. So within Xcode, if you hold down command and then click on the actual word NS array, you will get the header file, the nsarray.h file that comes up in the editor, and you can inspect any class type using that method. So you can command click on any class type and you'll get the header file for that class. Lastly, I want you to write a very simple application that creates an NS array that contains some NS string objects. They can be anything they want. They can be NS string 1, 2, 3, red, yellow, blue, red, blue, whatever, 3, X, it doesn't matter. Whatever those are, I want you then to log the contents of that array out to the output panel in Xcode using the NS log statement. Now, whether you do this in a loop or log them all out at once, I don't care. The point of the exercise is to assign a bunch of strings to an NS array and then view the contents of the NS array. And for extra credit, you can put the contents of NS array into some control that is viewable when you run the iOS application, say, on a device. Okay, so try these assignments, look at the videos, and really get a good understanding of what we're talking about.